So here's the general strategy that we used in the previous problem. First of all, we read the thing, right? So our first thing to do is to understand the problem. Read it carefully, figure out what information you have and what's being asked, right? Specifically, we figured out the dimensions, we were looking at stuff, we drew a picture, which is going to be my next thing. Almost always, for these, it will be helpful to draw a picture, right? Because there's going to be some relationships that you're going to have to figure out. Well, pretty much always, yes. So, drawing a picture and then label it, right? So, label not only the picture, but figure out stuff, right? So, label, introduce variables. Label picture. Okay, now, so we had done that. We had introduced the variables, we labeled the picture, and then sort of part of 1 with 3 is after you've labeled the picture, figure out what quantity you're going to optimize. So whether it's a maximum or a minimum or both. So in my example problem, we had to find the maximum area, right? So area didn't appear on the picture, but of course we could figure out the area of the thing in the picture, so we gave area a name, right? Then the other thing you want to figure out, let's see, right, then we want to find the relationships. Okay, so let's give this thing a name. Figure out what quantity you're going to optimize. We're going to call it Q for the purposes of the strategy. Of course, it was area, it can be volume, it can be cost. We'll do a lot of different examples. So find the relationships between the variables, the quantities, right? So then express Q as a function of only one variable. So that's the part that can be tricky to figure out if you don't have all these relationships, but you'll get there. You'll get the relationships, and then what you have to do is remember, what are we trying to do? We're trying to take the derivative of Q. So it has to be in terms of one variable. Put it in terms of one variable. And then, once you have Q in terms of one variable, you take the derivative, set it equal to 0, and find the extreme values, the critical points, right? Okay? Once you have, and you definitely make sure, you need to check that you have the right critical point. So what I mean is, by that statement, check to see that the answer is what you want. Like in the last problem, we came out with one number, 600. Do I necessarily know that that's the maximum? It did turn out that it was. And if you would set up the problem right, it should turn out that the number you get is the maximum. You may get two numbers. You have to figure out which one's the maximum and the minimum. You may have made a mistake, and the number that you get is the minimum. Or maybe you're looking for a maximum, the number is the minimum, and then you're supposed to conclude that actually the maximum happens at whatever the endpoints of the problem might be. So there's all these various things. That's what I mean. I tell you, make sure that once you get the number, you check that it's the number you want. Okay? And then the last step is to make sure you answer the question fully. because the question that's posed in the problem may be find the x value that minimizes such and such. Or it might be find the total distance, or it might be find these dimensions, or whatever they're asking. They may ask it in many different ways. You want to make sure that you answer the question that's being asked and not answer like the wrong question. So let's go ahead and do this for some more problems.